Okay, this is lesson 5.3, day 2. Here's the homework that goes along with it. We've got our problem of the week due Friday. Con is also due Sunday, and I'll tell you your minutes in a moment. Okay, here's the answers to the first part of last night's homework. Go ahead and pause it and check it. Second part, again, pause and check. All right, find this in your note packet. All right. We, last week, talked about graphing functions. And at this point, to graph these functions, all you are doing is making a table of values. Now, today, we are learning two terms, and I am telling you, you are going to need to know these. Continuous data are data where numbers between any two data values have meaning. Examples of continuous data include measurement of temperature, length, or width. Use a solid line to indicate continuous data. Continuous data would be something like this. Pretend I said f of x equals 2x plus 10. And our data, x is time in minutes, and y is temperature. Okay, pretend we've got like a little fire burner, a little Bunsen burner. This function, and I'm totally making this up, this doesn't mean anything, but after 1 minute, the temperature would be 12. Well, let me ask you a question. Does 1 minute, could it go 1.1 minutes? Yes, and the temperature would go up a little bit more. It's not going to jump from 1 minute, it would be 12. If I put in 2 minutes, it would be 14. Do you think if this was a real-life application and I had a warming tray, would the temperature jump from 12 directly to 14? No, it would go 12, 12.1, 12.2, 12.3, 12.4, up to 14. It would be a continuous increase. Okay? That is called a continuous function, where the numbers increase continuously. That's a great example. Time and temperature. If I am consistently heating something, the time ticks up, the temperature ticks up. Now, the other type of function is called a discrete data function. It is data that count items, such as number of people or cars. For discrete data, indicate each data item with a point. It is not a continuous line. Let's take that same function. F of x equals 2x plus 10. And I'm going to describe it this way. F is the number of tickets. Pretend you're going to a fair, okay? And it costs $10 to get into the fair. And then every ticket that you buy to ride the ponies costs you $2. Yes? If you buy one ticket, how much are you going to spend? $12. If you buy 2 tickets, how much are you going to spend? $14. In this scenario, can you spend $12.10? No. $12.10 doesn't mean anything on this particular set. Each ticket costs $2. So if you buy 0 tickets, you're paying $10. If you buy 1 ticket, you're paying $12. If you buy 2 tickets, you're paying $14. That is discrete data with the same exact equation. Up here, that was a continuous data set, same exact equation, but x and y mean something different. Does that make sense to you? This graph, continuous, would be a line, because as temperature increases, as time increases, increases, temperature increases at a steady rate. This one, as the number of tickets increase, it goes up by $2. It doesn't go up by 1 cent or part of a cent. It goes up by $2. So this would look like a whole bunch of dots. And we're going to look at an example. All right. So, for some cases like example 2 from yesterday's lesson. So, yesterday's lesson, example 2 said this. A local video store, you can rent, what is lesson 2? No. A local video store can rent a video game for $3. It costs you $5 a month. The function rule is C of V equals 5 plus 3V. I don't know yesterday, I don't know example 2. I think that that's wrong. Because this would be dots. It would not be a continuous graph. I don't know what they're talking about as far as example 2. This function would be dots. And it would make sense because if you rent 0 video games, it costs you $5. 1 video game, it would be $8 for the month. 2 video games, it would be 6 plus 5, 11. And it would be dots. You would use discrete data for this. All right. They must be talking about a different example too. All right, let's look at this. Suppose your group recorded a CD. Now you want to copy and sell it. One company charges $2.50 for making a master CD and designing the art for the cover. There is also a $3 charge to burn each CD. The total cost, P of C, depends on the number of CDs burned. Use the function P of C equals 250 plus 3C to make a table of values for the graph. Now, look what we did. Here's your function. They picked C is 100, 200, 300, and 500. You can pick whatever you want. Plug it in. Now, I have a question for you. Should that be a solid line or dots using this scale? Look at this scale. Each one of these is 100. This one will be a line using that scale. Why? Because isn't it increasing by $3? You actually think that we could, using this scale, these are hundreds down here, put enough dots to see each one? What if I did the same exact problem? Number of CDs and price. But I'm going to go 1, 2, 3, 4, 5. 1 CD would be $2.50 plus 3 times 1 is $2.53. 2 CDs would be $2.50 plus 3 times 2, $2.56. 3 CDs would be $2.59. 4 CDs would be $2.62. 5 CDs would be $2.65. Now, if I was doing 1, 2, 3, would it make sense that I would make the appropriate scale 1, 2, 3, 4, 5, and let's say that this is 250. So 0 is 250, 253. 1 CD is 253. 2 CDs is 256. That scale right here, I would do a discrete dot, dot, dot. Because with this scale, I can read it. this is a discrete function because it goes up $3 for every CD that you burn. All right. At a ball game, they charge $2 for a hot dog. The function C of H equals 2H describes the cost of H hot dogs. Make a table of values and graph this function. So, hot dogs and cost of the hot dog. If I buy 0, it costs 0. 1 hot dog will cost 2, 2 will be 4, 3 will be 6, etc., and so on. So, when I label my two axes, isn't this going to be cost? And this is number of hot dogs, because the cost is dependent on the number of hot dogs. I'm going to go by 2s, 2, 4, 6, 8, and I'm going to go by 1s down here. 1, 2, 3, 4, 5. 0 hot dogs cost $0. 1 hot dog is $2, 2 hot dogs is $4, 3 hot dogs is $6, etc., and so on. Would I connect that with a line? Casey, you're shaking your head yes. No. Because if you go to Mr. Hot Dog Man, am I ever going to have to pay $2.25 for this scenario? No, because hot dogs are $2. That's all they're selling. So you either pay 0, 2, 4, 6, 8, etc., blah, 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 blah. It is discrete because of the situation. $2 per hot dog. Does that make sense to you guys? All right. Your family is hiking uphill from a campsite 4,000 feet above sea level. You climb an average of 500 vertical feet per hour. The function H equals 4,000 plus 500 t relates your height above sea level. Is this going to be discrete or continuous? Discrete or continuous for this particular situation? Correct. Why do you think it's continuous, Justin? I'm not going by jumps, am I? I'm not jumping 1,000 feet. When I start walking, I'm going 1 inch, 2 inch, 3 inch, 4 inch, 5 inch, mile, blah, 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 blah. It's continuous. Okay? I keep walking, and I get further and further away. Now, if I was a giant, big, purple, jumping kangaroo that could jump 500 feet at a time, okay? Pretend I had superhuman kangaroo powers, and I could jump 500 feet at a time. Then it would become discrete, because I would go from 4,000, I'd do one jump to 4,500, and then I'd do another jump to 5,000. That's not realistic, right? Maybe I'd have Johnny Cobra stick, but whatever. That is continuous, because as I'm walking, I get further and further away. Okay, the function C equals 650t represents the cost of tickets in a basketball game. Is this discrete or continuous? This is discrete, because one person costs $6.50, 2 people cost $13, etc., and so on. There's no numbers in between. All right. The admission to a fairground is $3 per vehicle plus 50 cents per passenger. The total admission is a function of the number of passengers. Is this T of n equals 3 plus 50 cents times n. Make a table of values and graph. So, number of people and T of n. First of all, what is the minimum number of people that I need to have? 1, because somebody better be driving the car. It's not realistic for there to be 0 people because the car is not driving itself. So, 1 person will cost $3.50, right? Because the car costs $3.50 and then 50 cents per person. Okay. 2 people would cost $4. 3 people would cost $4.50. 4 people would cost $5, etc., and so on.